Welcome to this lesson on atomic structure. You'll need a copy of your atomic structure guided notes. To succeed in the atomic structure lesson, you will need to be able to identify 3 subatomic particles and compare their properties, distinguish the atomic number of an element from the mass of an isotope and use these numbers to describe the structure of atoms, and understand that an electron in an atom can move from one energy level to another when the atom gains or loses energy. The vocabulary you're going to need for today's lesson will be proton, electron, neutron, atomic number, mass number, isotopes, and energy levels. The properties of subatomic particles. Subatomic particles include protons, electrons, and neutrons. Let's talk about protons, electrons, and neutrons. A proton is a positively charged subatomic particle that is found in the nucleus of an atom, and it has a charge of +1. An electron is a negatively charged subatomic particle that is found in the space outside of the nucleus, and this has a charge of -1. And then a neutron is a neutral subatomic particle that is found in the nucleus of an atom, along with the proton. Comparing subatomic particles, protons, electrons, and neutrons can be distinguished by mass, charge, and location of the atom. This figure summarizes some of the properties of protons, electrons, and neutrons. Protons and neutrons have almost the same mass, but would take almost 2,000 electrons to equal the mass of one proton. Electrons have a charge that is equal to a proton but opposite. The neutrons have no charge at all. Protons and neutrons are located in the nucleus, but the electrons are located outside of the nucleus. Concept check number 1. Name 3 subatomic particles. Question 2. What 3 properties can you use to distinguish a proton from an electron? This would be a great time to pause the video, answer the question, and then resume. Question 1. Name 3 subatomic particles. 3 subatomic particles are protons, electrons, and neutrons. Question 2. What 3 properties can you use to distinguish a proton from an electron? 3 properties that you can use to distinguish a proton from an electron are mass, charge, and location in an atom. The atoms of any given element always have the same number of protons. For example, there is 1 proton in the nucleus of each and every hydrogen atom. Therefore, hydrogen is assigned the atomic number 1. The atomic number of an element equals the number of protons in an atom of that element. Hydrogen are the only atoms with a single proton. Atoms of different elements have different number of protons. Carbon is assigned the atomic number 6 because carbon atom has 6 protons. You can use the atomic numbers to refer to the elements, like the names and symbols, because each element has a unique number of protons. The atomic number tells how many protons are in the nucleus of an atom. But how do we know how many neutrons are in the nucleus? We must look at the mass number for this information. The mass number of an atom is the sum of the protons and neutrons in the nucleus of that atom. Finding the number of neutrons. The number of neutrons equals the mass number minus the atomic number. For oxygen shown here, the mass number is 16 and the atomic number is 8. The number of neutrons equals 16 minus 8, which equals 8 neutrons. Finding the number of neutrons. Let's apply what we've learned. This is an example of fluorine. How many protons are in fluorine? The atomic number of fluorine is 9, so there are 9 protons in fluorine. Remember that the amount of protons that are in an element have is equal to the atomic number. How many neutrons are in fluorine? The mass is 19. So 19 minus 9 equals 10 neutrons. Yep, chemistry can be that easy. Simple addition and subtraction. Concept check number 2. Which of the characteristic of an atom always varies among atoms in different elements? 2. What do neutrons and protons have in common, and how are they different? Number 3, identify the number of protons and neutrons for the following elements, chlorine and neon. Now would be a good time to pause the video, try to answer the questions, and then return. Which characteristic of an atom always varies among atoms of different elements? The atoms of any element have different number of protons. And atoms of all other elements. Question 2, what do neutrons and protons have in common, and how are they different? Neutrons and protons are both located in the nucleus and have almost the same mass. Protons are positively charged and neutrons have no charge at all. Identify the number of protons and neutrons for the following elements. Chlorine, 17 protons and 18 neutrons. The atomic number is 17 and the mass number is about 35. Neon has an atomic number of 10, so there's 10 protons, and the mass number is about 20, so 20 minus 10 is 10. Every atom of a given element does have the same number of protons and electrons, but every atom in a given element does not have the same amount of neutrons. Isotopes. Isotopes are atoms of the same element that have different numbers of neutrons and different mass numbers. For example, every atom of carbon has 6 protons. Some atoms have 6 neutrons, a mass number of 12. Some carbon atoms have 7 neutrons for a mass number of 13, and some have 8 neutrons for a mass number of 14. When it is important to distinguish one carbon isotope from another, carbon isotopes come in 3 forms. Carbon-12 is the most abundant. Carbon-12 and carbon-13 are considered stable isotopes, since they do not decay into other forms or elements over time. The rare carbon-14 isotope contains 8 neutrons in its nucleus. Unlike C12 and C13, this isotope is unstable and radioactive. Over time, carbon-14 atom will decay into a stable product. Isotopes of an element have the same atomic number, but different mass numbers, because they have different numbers of neutrons. Each electron in an atom has a specific amount of energy. If an atom gains or loses energy, the energy of the electron can change. Energy levels are the possible energies that electrons in an atom can have. To understand energy levels, picture them as steps in a staircase. As you move up or down the staircase, you measure how your position changes by counting the number of steps you take. You can only move up or down in a whole step manner. The same is true for electrons. They can't be between energy levels. The landing at the bottom of the stairs is the lowest energy level in an atom. Each step up represents a higher energy level. The distance between 2 steps represents the difference in energy between 2 energy levels. There would need to be a different staircase for each element, because no 2 elements have the same set of energy levels. An electron in an atom can move from one energy form to another when it gains or loses energy, and the size of the jump between the energy levels determines the amount of energy is lost or gained. What energy is there that electrons can move from one energy level to another? Scientists can measure the energy gained when electrons absorb energy and move into a higher energy level. They can measure the energy released when the electrons return to a lower energy level. The movement of electrons between energy levels explains the light you see when fireworks explode. The light is a form of energy. Heat produced by explosion caused some electrons to move to a higher energy level. Then those electrons move back to lower energy levels. They emit energy. Some of that energy is released as visible light. Because no two elements have the same set of energy levels, the different elements emit different colors of light. Concept check number 3. How are isotopes of an element different from one another? If an atom has an atomic number of 1 and a mass of 3, how many protons, electrons, and neutrons does the atom have? Number 3. When is an electron in an atom more likely to move from one energy level to another? Now would be a great time to pause the video, try to answer the questions, and then resume play. Question 1. How are the isotopes of an element different from one another? Isotopes of an element have the same atomic number, but different mass numbers because they have different number of neutrons. 2. If an atom has an atomic number of 1 and a mass number of 3, how many protons, electrons, and neutrons are in the atom? 1 proton, 1 electron, and 3 neutrons. Note, this is an isotope of hydrogen called tritium. Number 3. When an electron in an atom is more likely to move from one energy level to another. Electrons are more likely to move from one energy level to another when atoms gain or lose energy.